Hey everyone, I'm here to discuss about the Laplace transform of sinusoids and analysis by Laplace transform.
Laplace transform is widely used in engineering applications that is used in transforming from time domain to frequency domain. So, the general equation here is Laplace of f in terms of time is equal to integral of f in terms of time times e to the power of negative st dt from 0 to infinity, where L is the Laplace integral and the variable s is a complex variable. Before proceeding in my actual topic, let us recall that in our advanced math discussion, we have discussed about the basic Laplace transforms. So, the Laplace of 1 is equal to 1 over s. The Laplace of t is equal to 1 over s squared. And the Laplace of t to the power of n is equal to n factorial over s to the power of n plus 1. And the Laplace of e to the power of positive negative bt is equal to 1 over s plus minus b. Laplace transform of sinusoids. Sinusoids refer to the signals sine and cosine. Remember that in our advanced mathematics, we have discussed about the Euler's equation. So the Euler's equation of sine is equal to e to the power of j omega t minus e to the power of negative j omega t all over 2j. And the Euler's equation of cosine is equal to e to the power of j omega t plus e to the power of negative j omega t all over 2. In evaluating the Laplace of sine, we can use the Euler's equation. Remember that e to the power of positive and negative bt is equal to 1 over s plus minus b. So we can substitute the formula here and here. So the Laplace of sine omega t is equal to the Laplace of e to the power of j omega t is equal to 1 over s minus j omega, and the Laplace of e to the power of negative j omega t is equal to 1 over s plus j omega over 2j. Reciprocating the 2j, so it's equal to 1 over 2j over s minus j omega minus 1 over 2j all over s plus j omega. Cross multiply, so we can obtain 1 over 2j s plus j omega minus 1 over 2j s minus j omega all over the product of the denominators s minus j omega and s plus j omega. Distribute the values. So s over 2j plus j omega over 2j minus s over 2j plus j omega over 2j all over s times s is equal to s squared and negative j squared is equal to 1. So it's equal to s squared plus w squared. And we can cancel this and this, and the j, so the remaining values are w or omega over 2 plus omega over 2 times s squared plus w or omega squared. It's equal to 1 half plus 1 half is equal to 1. So w all over s squared plus w squared. So the Laplace of sine omega t is equal to w omega over s squared plus omega squared, such that s is more than 0. Laplace of cosine omega t is equal to 1 over s minus j omega plus 1 over s plus j omega all over 2. Take the reciprocal, so 1 half over s minus j omega plus 1 half over s plus j omega. Cross multiply, so 1 half times s plus j omega as 1 half times s minus j omega all over the product of s minus j omega and s plus j omega. Distributing the values, so s over 2 plus j omega over 2 plus s over 2 minus j omega over 2 all over s times s is equal to s squared and negative j squared is equal to 1. So w times w is equal to w squared plus w squared. So cancel these values. So s over 2 plus s over 2 over s squared plus w squared. So s over 2 plus s over 2 is equal to 1. So the Laplace of cosine omega t is equal to s over s squared plus omega squared such that S is more than 0. Using the Euler's equation, Laplace of sine 4t is equal to the Laplace of e to the power of j omega t 1 over s minus j 4 minus Laplace of e to the power of negative j omega t 1 over s minus plus j4 all over 2j. Reciprocate the values, so 1 over 2j all over s minus j4 minus 1 over 2j over s plus j4. Cross multiply 1 over 2j times s plus j4 minus 1 over 2j times the quantity of s minus j4 all over the product of the denominators s minus j4 and s plus j4. Distributing the values, so s for 2j plus j4 over 2j minus s over 2j plus j4 over 2j all over s squared plus 4 squared. We can cancel this, so the remaining values are j4 over 2j plus j4 over 2j all over s squared plus 4 squared. Simplify these values, so we can cancel j and simplify this to 2 plus 2 is equal to 4. So 4 over s squared plus 4 squared. So the Laplace of sine 40 is 4 over s squared plus 4 squared. Example number 2. Find the Laplace transform of cosine 40. Laplace of cosine 40, so is equal to e to the power of j4t plus e to the power of negative j4t all over 2. Finding the Laplace of both this here and this, so it's equal to 1 over s minus j4 plus 1 over s plus j4 over 2. Reciprocating the values, so 1/2 over s minus j4 plus 1/2 over s plus j4. Cross multiply, so 1/2 times s plus j4 plus 1/2 s minus j4 all over the products of s minus j4 and s plus j4. So distributing the values, s over 2 plus J4 over 2 plus S over 2 minus J4 over 2 all over S squared plus 16. Cancel. So the remaining is S over 2 plus S over 2 all over S squared plus 16. S over 2 plus S over 2 is equal to S. So S over S squared plus 16. And transforming it to its general form, so the Laplace of cosine 40 is equal to S over S squared plus 4 squared. In a series RLC circuit, resistance is equal to 2 ohms, inductance is equal to 0.10 henries, and capacitance is equal to 0.10 farad. Write the equation of the circuit if F0 is equal to 0, voltage equation with E in terms of T is equal to 120 volts as a source voltage. Before proceeding, let us recall about our topic about the time domain. So the current and the voltage relation in the time domain of a resistor is V T is equal to R times I in terms of current. So by operational Laplace transform, Laplace of Vt is equal to Laplace of R times I t. So it's equal to R because it is considered constant. Laplace of I t. So Vs or final voltage is equal to R times the final current or the Is. The current and the voltage relation in the time domain in an inductor is Vt is equal to L times d over dt times I in terms of time. So by operational Laplace transform, Laplace of V t is equal to Laplace of L times I prime t equal to L Laplace of I prime t. So Vs is equal to L times S I S minus I O or the initial current. So Vs is equal to SL times IS minus L I O. A capacitor in the S domain. The current and voltage relation in the time domain is expressed in I T is equal to C times D dt times V in terms of T. So by operational Laplace transform, the Laplace of I in terms of T is equal to Laplace of C times V prime T. So it's equal to C Laplace of B prime T. So I S is equal to C times the quantity of S V S minus V O, which is the symbol of the initial voltage. So I S is equal to S C times V S minus C V O. We will solve this equation by KVL. So let's assign values. So here positive, negative, positive, negative, positive, negative. And the direction of the current is here. So by KVL, the voltage is equal to the time domain of resistance, so R I plus time domain of the inductance is equal to L di over dt plus the equivalent Thevenins of the capacitor charge 1 over C I dt. So 120t is equal to 2I plus 0.1 di over dt plus 1 over C, so 1 over 0.10 is equal to 10 ohms, 10 farad I dt. So by Laplace transform, Laplace of 120t is equal to 2 Laplace of I plus 0.1 Laplace of di over dt plus 10 integral of I dt. Laplace of 120t is 120 over s squared is equal to Laplace of I, so 2is plus the Laplace of the inductance as stated in the time domain is equal to 0.1 s is minus the initial current IO plus 10 is over s. So evaluating the is, so is equal to 1200 s plus 10 squared, and where the initial current is equal to 0. Finding the current in terms of time, we need to have an inverse Laplace, so we will have an inverse of this. So I in terms of time is equal to inverse Laplace of is. So I in terms of time is equal to 12 minus 12 e negative 10 t minus 120 e to the power of negative 10 t. By further evaluating the values, so we will get the result here.